Welcome guys to our today's tutorial where we'll handle question 1 up to 10 of Mathematics Paper 1 2024 GCE. Thank you so much for the returning subscribers for always coming back to watch our videos, and if you are new to our channel, we are kindly asking if you can hit the subscribing button there and make sure you also hit the notification bell so that whenever we post a new video you are notified. Let's just dive into our today's tutorial. Okay, so the first question is saying evaluate in brackets, that is 8 over 27 to the power 2 over 3. The power is also in fraction form. How do we handle this question? Very simple. You should know that if your power is in fraction form, it simply means the denominator for your power represents the root value. So in this case, our denominator on this power is a 3, meaning the value for our root is 3, so it's a cube root. So we'll write it in this way. Okay, we'll introduce a cube root to both 8 and 27, okay, because they both carry that root. Okay, the next we're going to find a number that we can multiply 3 times to get 8. That is the cube root of 8. Same with 27. Cube root of 27, a number we can multiply 3 times to get 27. Do you know the numbers? Perfect. A 2 and a 3. Good. The power still comes. We haven't used that. So 2 over 3. Those are the cube roots for the numbers 8 and 27 respectively. Now we can take the power now. What is 2 to the power 2? Good, it's a 4. And then 3 to the power 2? Perfect, it's a 9. So the final answer is 4 over 9. And that is our answer there. Okay, we proceed to question 2. Simplify 4 open brackets x minus 2 close bracket plus 3 open bracket 2x minus 3 close bracket. Simplifying this question, if you remember, we had a topic, a tutorial where we talked about simplifications, factorizations, okay, different type of factorization. So when you just look at this one here, this is a grouping factorization because the terms are more than 3. So first step we are going to take is to remove the brackets. Okay, we are going to multiply the numbers that are on the left side of these brackets so that we remove the brackets. So the first bracket we have a 4 outside. The second bracket we have a positive 3 outside the brackets. So we're going to use those numbers to multiply in those respective brackets and they'll be removed. So the first part we're going to have 4 times x, which is 4x, then 4 times negative 2, which is a negative 8, okay, then positive 3 times positive 2x, that is, good, positive 6x, then positive 3 times negative 3. Okay, next we are going to put the like terms together. So the 4x and the 6x, okay, those are the like terms. So put them together. Don't change their signs. Here they are not crossing any equal sign. We are just rearranging, okay? Then the negative 8 and the negative 9 there. So we can add and, okay, the like terms. So 4x plus 6x, that is giving us 10x. Negative 8 minus 9 will give us a negative 17. Same signs, we maintain the sign and add the two numbers. Okay, that is our final answer. We go to question 3. Again, another form of factorization. Now, fortunate enough, this one is already factorized for us. We are almost done. This is just the final phase of this question. It's a quadratic equation for that matter. Okay, so what we're going to do, we'll just go direct into using the product rule. So the product rule, if we have a times b, and these they are equal to 0, we simply say if a times b is equal to 0, then a is equal to 0, or b is also equal to 0. Okay, that is what the product rule states. Okay, so in this case, when you look at the first bracket and the second bracket, these, we say the first bracket is representing A, the second bracket is representing B. So the same way we have broken them down this side, it's the same way we're going to do it here. So we'll say 3x minus 5 will equate it to 0. Okay, it's the A. So we'll have 3x minus 5 equals to 0. The second answer will come from the second bracket, which is x plus 2 equals to 0. From here now we can solve them. Those are equations in one variable. Okay, so we can put the like terms together. So this side, on the left hand side, the negative 5 has to cross, okay, needs to go where the like term is, which is a 0 there. So this side we're going to remain with 3x equals to positive 5. Okay, here it's direct, so when the positive 2 crosses, it becomes a negative 2. So that's the final answer on the right here, x equals to negative 2. We finish up this one. Okay, so we are going to divide with the 3 on both sides. Okay, so dividing with the 3, we remain with x equals to 5 over 3. And then this answer here, we can write it in mixed fraction form. Okay, so the 3 goes into 5 one time. Okay, and then the remainder is a 2 over 3. So the final answer here on the answer grid, on the where we're putting our answers, the final answer will be in fraction form, which is 1, then 2 over 3. Okay, the other answer is x equals to negative 2. Okay, perfect. We go to question 4. Factorize completely. Okay, this is another form of factorization. If you watched that video for factorization, then this should be a walkover for you. All these 3 questions that we are from solving. Okay, so here we're not going to panic. When you have 2 terms and there is a power 2, what you're going to do, if you find what is common. Okay, so in this case we'll start with the numbers. Okay, what number can go into a 7? The same number going into another 7 there. It's a 7 itself. So 7 is common. Do we have common letters? Definitely not. So only 7 is common on these 2 terms here and also here. Okay, so you are going to write down what has remained. So here when we divide 7 into 7, it's a 1. 1 times x squared, it is x squared. Here, negative 7 divided by 7, it will give us negative 1. So it will be in this form. If you remember what we used to do, when said factorize completely, here in this case, what remains inside the brackets, it has to be completed in form of difference of 2 squares. Okay, so the x has a power 2 already. It means the number which we need to introduce a 2 on is a 1. Okay, so meaning a 1 has to be changed into index form. It should have a power 1. A power 2. So that when we multiply 1 times 1, it should give us the number which is here. Okay, so a number that we can multiply 2 times to get 1, it's a 1 itself. So the second step will be like this. Okay, so we'll have x squared minus 1 squared. Now, those are difference of 2 squares. So the first bracket is going to carry x minus 1. The second bracket is going to carry x, and then here we'll have a plus. Reason why we're putting a plus, it's because we are just emulating, okay, emulating the format of difference of 2 squares, okay, of perfect squares, in other words, of difference of 2 squares, okay. So in this case, the final answer will be 7, and okay, open bracket, the first bracket will have a minus, the second bracket will have a plus. Okay, so that is our final answer there. We'll go to question number 5. Use set notation to describe the shaded region in the Venn diagram below. Okay, very simple here. When you look at your A, it has been left out completely. The entire circle for A has been left out. What has been shaded is just B and the C. So here, the A is complement, definitely, okay, because it has not been shaded. meaning complement of set A. When you say complement, it simply means elements that are not in set A. Now, when we are shading, if we are getting elements, if I just say A complement, we get elements including the elements that are in the universal set in here. Okay, in here we also get elements, but the universal set has not been shaded, meaning for us to to get the elements that are in B and C, it means there is an intersection to which elements? The elements that are in B and C. So the set notation will be A complement intersection B union C. Okay, we proceed. Question 6. A businessman got 800 shares worth 7,200 kwacha, 0.00 ngwe. What was the cost of each share? Okay, a simple expression here. If 800 shares, this person paid 7,200. What about one share? X, we don't know. From here, we are going to cross multiply. Okay, so 800 times X, that is 800X. 1 times 7,200, it will still be 7,200. Okay, so we have it in this way. Second step, we want to remain with X, so we're going to divide on both sides with 800. Okay, so we remain with X equals to, okay, so in this case, the zeros we're dividing. Okay, so the zeros here can be cancelled. 8 goes into 72 how many times? Okay, 8 into 40, that is 5 times. Okay, so it goes there 9 times. Okay, meaning each share was costing 9 kwacha 00 ngwe. So 9 kwacha 0.00 ngwe per share. Okay, we've answered that. We go to question 7. The sequence 20, 17, 14 is an arithmetic progression. Find the 9th term. In paper 1, it's important, if it's a question that requires you to use a formula, it's important to first of all remember the formula and write it down before you do anything. Okay, so nth term, the formula for nth term is Tn equals to A plus open bracket n minus 1 times D. So now when you write down the formula, it becomes easy for you to pick whatever you want from the question. So the A here represents the first term, meaning T1. Okay, the first number in that sequence is represented by A. This n here represents the position. Okay, in this case, the position that we are finding the number for is position 9. Third is D. D is representing the common difference. Common difference. Okay, so first step is to find the common difference because we don't have it. So common difference is equal to second number in that sequence minus the first number in that sequence. Okay, so the second number is 17, the first number is a 20. So 17 minus 20 will give us what? Good. Different signs we're going to subtract and get the sign from the bigger number. Perfect. So subtracting that will give us a negative 3. Now we can use it on our formula to find the 9th term. So T9 equals to 20 plus, in brackets, that is 9 minus 1, then close, times negative 3. Okay, so we first of all deal with what is in the brackets. So we have 20 plus what is 9 minus 1, that is 8, times negative 3. Okay, here. So 20 plus 8 times negative 3 will give us, good. So 20 plus negative 24. Then here, positive times this negative which is inside, it will give us a negative. So we're going to have 20 minus 24. Okay, so 20 minus 24, same concepts of integers, different signs, we subtract and we'll get the sign from this bigger number, the 24. So 20 minus 24 will give us, good, negative 4. That is the 9th term, okay? We proceed to find the sum of the first 10 terms. Finding the sum of the first 10 terms. Again, we'll need to use the formula. So first step is to write down the formula. Sum of nth term is equal to n over 2, open bracket, that is 2a plus, open another bracket inside. Okay, then n minus 1, close bracket times d, then close square bracket. From here, almost everything in fact we have here, so we just substitute. So S10 equals to, where there's n there, we're going to substitute with a 10 because we are finding the sum of 10 terms. So the n is 10. So 10 over 2. Then 2 times our a here is the first number. So first number is a 20 plus n is 10 minus 1 times common difference we found. It was a negative 3. So times negative 3. Okay. So here the 2 can go into 10. That is 5 times. This is the 5 you are seeing outside. Okay, so 5 times 2 times 20, that is a 40 you are seeing here. And then 10 minus 1, that is a 9 times a negative 3 there. So 9 times negative 3 will give us a negative 27. You can see I'm separating the positive and the negative with brackets there. Okay, so again, positive times negative, it will leave us with a negative. So 40 minus 27. Okay. Different signs, we subtract and get the sign from the bigger number. In this case, the bigger number is positive. So the final answer when we subtract, it will be a positive. So 40 minus 27 is a positive 13. Okay, so 5 times 13, perfect, it will give us 65. So sum of 65 terms is, sum of 10 terms is 65. Okay, we proceed to question 8. A fair die is rolled once. Find the probability, find the probability of a 4 showing up. Okay, when you're dealing with a die, okay, you should know to say numbers there, it has got 6 faces. Okay, each number there is appearing once, meaning all the numbers there, they've got the same probability. Okay, whether you pick a 1, you pick a 6, you pick a 4, you pick a 5, they've got the same probability. They are all appearing once. Okay, so the possible outcome is 1. Okay, probability of picking a 4, the possible outcome is 1 out of how many faces that are there? 6. So the probability of a 4 showing up is 1 over 6. Okay, then we go to B, which is under trigonometry. Okay, in the diagram below, ABC is a straight line. Okay, AD is equal to 5 centimeters, BD is equal to 13 centimeters, and angle BAD is equal to 90 degrees. Okay, find the value of tan DBC, this angle which is outside here. Okay, we're using tan. Now, for us to find that one there, because it is not a complete shape, so we cannot go ahead and solve it using the ratios, the SOHCAHTOA, no. So what we're going to do, this is an opposite angle to this angle which is inside here. Okay, so when we find the tan of this angle here, which is inside, this angle here, inside, when we find the tan of this angle, then we'll take the opposite to that, okay, by introducing the negative, then it will give us this angle which is outside. Okay, so first of all, if we say tan is equal to what? Tan is equal to adjacent? No, it's equal to opposite. Okay, good. Opposite over adjacent. Okay, so if you look at the angle B here, which is inside, the opposite is 5, okay, which is AD, but the adjacent we don't have any value. AB, we don't have anything. So it means our first step is to calculate AB first of all. Using what? You are right. Using Pythagoras. Okay, so on this triangle, using Pythagoras, okay, we'll say BD squared. Okay, this is the side which is opposite to the 90. So this is the hypotenuse. Okay, so BD squared equals to then AB squared plus AD squared. Substituting the values, BD squared is what? 13 squared. Okay, then AB, we don't have anything. AD, we have a 5, so 5 squared. Next, 13 squared, when we say 13 times 13, okay, 13 times 13, you'd find that when you multiply 3 times 3 there, that is a 9, 3 times 1, that is a 3, okay, then 1 times, so place order 1 times 3, that is a 3, 1 times 1, that is 1, okay, that is a 9, okay, then 6, then 1. So when we multiply 13 times 13, we are getting 169, and then 5 squared is 25. Okay, from here, we just want to remain with AB squared. So this 25, positive 25, it has to cross the equal sign. Okay, it has to go where the 69 is, or where the 169 is. So we'll have AB squared equals to 169. When 25 crosses, it becomes minus 25. So 169 minus 25, good, it is 144. Okay, from here, since we have 144 as our answer, that is not final because the AB still has a power 2. So we need to introduce, let me write it from here, we need to introduce the square root on both sides so that the square root here and the power 2 will cancel. So we remain with AB. Then the square root of 144, a number you can multiply 2 times to get 144 is what? Perfect, 12. So AB is equal to 12. So here where there is AB now, we have a value which is 12. We can go ahead and find the tan of this number, of this angle which is inside here. So tan ABD, okay, ABD, which is the angle which is inside, is 5 over 12. Opposite over adjacent. So opposite is 5, adjacent is 12. Then I said tan DBC is the opposite of this angle that we're just from finding, the 5 over 12. Opposite in terms of sign. Okay, so for us to get the one which is outside, we just introduce a negative on the 5 over 12. Okay, so the final answer is tan DBC is equal to negative 5 over 12. Okay, we're done there. We go to question 9. So 9a is saying, given that the universal set E, okay, it has values there, it has elements, and then P has elements, Q has also elements. They're saying list P complement intersection Q. First step, one operation at a time. So we are going to first of all find the complement of P. Okay, so P complement, it simply means the elements that are not members of set P, but they are in the universal set. So we are going to cancel out all the elements that are in set P from the universal set. What remains is what we're going to write. Okay, so if we cancel out the 2, okay, we cancel out the 4, we cancel out the 6 and the 8, okay, what remains is 1, 3, 5, 7 and 9. Okay, the next, we are now going to introduce the last part, which is intersection with Q. Intersection simply means what is common. So if you look at this P complement set and the set Q, which is here, you can see that there are some elements that are similar in there. Which are those? Good. A 3, 5 and a 7. That becomes your final answer there. So 3, 5, 7 is the P complement intersection Q. Okay, we go to the next question B. The diagram below shows trapezium S and trapezium T. Describe fully a single transformation which maps trapezium S onto trapezium T. This is transformation. Okay, under transformation in paper 1, we have three that come in paper 1. That is translation, reflection, and rotation. Now, when you look at the shape on top here and the shape on the bottom, it's more like it has just been, it's the same shape, same size. And if you look at the distance from this line here to here and the distance from here to here, it's the same. Okay, same size of this shape. Okay, looks as if it has just been flipped on the other side. In this case, this is a mirror. There's no rotation that has taken place. Okay, this is a mirror, so there is reflection. Okay, the similar object has just been reflected on the other side, so this is a reflection. Okay, so this, we'll write it down in written form. We'll say it is a reflection in the line y equals to 0. Okay, so the y equals to 0, this is the x-axis, this line here, that is the mirror line. Okay, this is the mirror which is reflecting this object to form that image, the T. Okay, we're done there. We go to our last question. Question 10a. Given that a is equal to 2, -1, then 3, find A transpose. So the T that is on top here, it represents transpose. To transpose a matrix simply means to change the rows into columns, or the other way around, you change the columns into rows. Okay, so in this case, this entire row will be changed into a column, like so. Okay, so the final answer will look like this. Okay, so we have 2, -1, then a 3. That is the transpose of A. Okay, then given that A is equal to, we are going for B, given that A is equal to 3, 2, and then B is equal to 1, -2, find AB. So the AB we are trying to find, it's a multiplication of matrix A and matrix B. Okay, so in this case, we write it down. So if you look at the easiest way to know the order of your final answer, the first matrix is a 2 by 1. Okay, my second matrix is a 1 by 2. Okay, so I'm going to get the row for the first matrix, which is 2, and I'm going to get the column for my second matrix, which is a 2 again. So this will be the order of my final matrix. Okay, when I multiply, remember we multiply row by column. Okay, so in this row where there is a 3, there is only one number, but it has to be multiplied to 2 columns. Okay, so the first part, it will be 3 times 1. On that position, we are done. Then we'll leave space. We'll go again 3 times -2. Okay, the same procedure will be repeated even on the second element in this column. Okay, so we're going to have 3 times 1, then leave space because you're going to the second column, 3 times -2. We are done. We come to the second element in this second row. Okay, that is 2 times 1, again 2 times -2. Okay, when we multiply 3 times 1, it's a 3. 3 times -2, it's a -6. 2 times 1, it's a 2. 2 times -2, it's a -4. Notice the order of this matrix. It's a 2 by 2, just like what we predicted there. So you can know the order of your matrix before you begin to multiply, so that you see if you're doing the correct thing or not. Okay, so thank you very much, guys. We've come to the end of the part 1 of mathematics paper 1 2024 GCE. Okay, so see you in the next video, which will be part 2. We'll start from question 11.